Okay, so I'm going to work through some examples that will help you with your assignment worksheet, starting with this one, the question that is similar to the question 4 on your P4 worksheet. You're asked for 4 position isomers of a small molecule. The one that you're asked for is dibromoalkane, and I'm going to do dichloroalkane here, which is very similar. The only difference is that I'll be using chlorine and you'll be using bromine. So there's 4 different versions of this isomer that can possibly exist. To start with, just remember that each end of a line or corner in this molecule is a carbon atom. Each carbon makes 4 bonds, and we infer the number of hydrogens. So for example, this carbon, we can see 2 bonds, so there must be 2 hydrogens attached to this carbon. And these end carbons, we can see 1 bond, so they must have 3 hydrogens. Where they've got hydrogens, we can replace with our chlorine or bromine atom. So with our first one, we might start by saying both chlorines are attached to this end carbon. Remember, it can make 4 bonds, and it has 2 of its hydrogens are gone, and instead it is bonding to 2 chlorines. Another version of this that we could have might be both of those chlorines on that middle carbon there. The next one you might be tempted to do is to put both of your chlorines on this end one, which I'm going to do here, the bond tool, sorry. But if you do that, I just want to show you that this isn't a different molecule to this one. We could pick this one up and turn it over and superimpose it on this one. So these 2 are the same molecule. Okay, so something that we could do. We could look at attaching our chlorines, 1 on the end and 1 on the middle. So this time, not both on one of the carbons, spreading them out. And the final version of that would be 1 on the end as before, not 1 on the middle because that will be the same again, but 1 on the other end there. And then you have 4 different isomers. They all have this formula. None of them are the same molecule as any of the others.